Alright, this is lesson 2.3 of our Pre-Calc 12 class. Unit 2 is called Polynomial Functions. Lesson 3 is called Methods of Factoring Polynomials. So as we ended the last lesson, we talked about intercepts, and y-intercepts are pretty easy to find, whether from a graph or from an expression. X-intercepts, not so much. So we're going to spend some time on just x-intercepts algebraically. And I'm going to show you three methods today, and they're called long division, synthetic division, and box method. And I'm going to, by the end of the video, tell you why box method is my favorite and why you should do it too. So long division ties back to our elementary practice of doing long division. And so a quick refresher for you. Here's how you do it. Like we say, okay, we have a number we're dividing by. 324 is divided by 12. We say, all right, 12 goes into 32 two times. 12 times 2 is 24. So if we take away 24 from 32, we have a remainder of 8. Then we take our next number, 4, bring it down. 84. How many times does 12 go into 84? Well, it goes in 7 times. 7 times 12 is 84. So if we subtract 84, we have no more remainder, 0. So that shows us that 324 divided by 12 is 27. So we're going to apply that idea to polynomials. So if I take a polynomial and I divide it by 3x minus 4, I'm saying, okay, I think this gives us one x-intercept for our polynomial function. So if I divide it out, I can simplify this algebraic expression to find more x-intercepts. That's the big idea we're going for here. So I'm looking at just the first two terms. And when I divide this thing, I'm looking at just that first term. I have 3x to the power of 3. What do I multiply 3x by to make it look like 3x to the power of 3? Well, I'm going to multiply 3x by x squared. 3x times x squared is 3x to the power of 3. So if I multiply the whole term, 3x minus 4 times x squared, I get 3x to the power of 3 minus 4x squared. I'm going to subtract that. Because we have x squared taken out, I'm going to subtract that from our original polynomial. 3x to the power of 3 minus 3x to the power of 3 is a wash. 0 cancels out. 17x squared minus negative 4x squared will be the same as 17 plus 4 will be 21x squared. So now we're going to bring down the third term, minus 16x, and we're going to make our 3x look like this. So 3x times 7x would be 21x squared. So I'm going to take 3x minus 4, multiply it by 7x, and get 21x squared. And then 7 times 4 is 28, so minus 28x. If we subtract this from our polynomial, the x squareds wash out. Negative 16x minus negative 28x is like negative 16 plus 28x, that'd be 12x. Bring down our final term, minus 16. 3x minus 4. If I take the 3x and multiply it by 4, I get 12x. So 3x minus 4 times 4 would be 12x minus 16. And when I take 12x minus 16 and I subtract 12x minus 16, everything washes out. And so long division says that we can divide this out. X squared plus 7x plus 4 would be our solution, or our quotient. There's another method called synthetic. So we can take the same problem, and we could, if we do 100 of these problems using long division, we will start to notice some patterns and how to key in on specific parts of this process that is really all we care about. The x and their powers don't really matter so much as far as placeholders, but they don't change any calculations. So if we take just the coefficients, 3, 17, negative 16, negative 16, and they're written here in blue, and we take our divisor and we solve for x. Because we have a 3 here, we're going to say, okay, 3x minus 4, our number we want to solve for or our x-intercept would be 4/3. I'll put that there. And then because there's a 3 here, and this is where synthetic is a little tricky, because there's a number in front of the x besides 1, we're going to divide by that number before we get our final answer. Anyways, so we have our setup. We have our coefficients from our polynomial. We have our 4/3 from our divisor. And we're going to do synthetic. So I take the 3, the biggest term. I bring it below the line. I take that 3, multiply it by 4/3, and put the answer right here. 3 times 4/3, or 12/3, or 4, goes right here. Now I have a 17 on top of a 4. Add those together, I get 21. Take the 21, multiply it by the 4/3. You get 28. That goes right here. Combine the negative 16 and the 28, you get 12. Take the 12, multiply it by the 4/3 again. Put that number over here, you get 16. Combine the negative 16 and the positive 16, and there's a 0. So this is what I would call black magic. It's a synthetic division is a process for doing dividing polynomials. It works really fast. The only catch is it's a tricky formula, especially when you put a number greater than 1 in front of the x, or any number besides 1 in front of the x. Not doable. It's very doable, and we could spend a couple days mastering it, and you can do that. But we don't have to. There's another way. So let me show you this. In the past, we talked about box method, and we used box method to multiply polynomials. And so we can use box method to factor polynomials. And if we have a divisor, like 3x minus 4, we can divide polynomials using box method. So if I draw a box, it's a big polynomial, so I don't know how wide it's going to be, but I do know it's going to be too tall, or 2 rows. 3x minus 4. Now, the top left term would always be the biggest degree term, or our leading term. So I can just take our leading term and put it right there in that top right box. If we have 3x here, and if 3x to the power of 3, our leading term, is right here, I know this has to be x squared, because 3x times x squared is 3x to the power of 3. Well, if this is x squared, then that gives us this box right here, because we have negative 4 times x squared. Gives us this box right here. Now here's the catch. If I have negative 4x squared in this box, I know this box has to be an x squared. And so I might take this, to figure out this number 21, I say, okay, I have negative 4, I need to have positive 17. So what can I add to negative 4 to get to positive 17? I gotta add 21. That's how I know 21 goes in this box. So negative 4x squared plus 21x squared is 17x squared. That box works. Now that I know this is 21x squared, I can find the number on top of the box, because 3x times what equals 21x squared? Well, 3x times 7x does. And so that's how I get the 7x. Now that I have the 7x, I can figure out this number right here. 7x times negative 4 is negative 28x. And then we just have this domino effect. So again, I know this is going to be an x term, so what number does this have to be? Where does this 12 come from? Well, I needed negative 16. So negative 28 plus 12 gives me negative 16. That's how I know this is 12x. Once I know this is 12x, I can find the 4. 3x times 4 is 12x. Once I have the 4, I can find the last box. 4 times negative 4 is negative 16. And notice our last box matches our constant term. So now I know, right here, x squared plus 7x plus 4, that is our solution, or our quotient. And I would argue this little box right here is less work than long division for sure, and it's less confusing than synthetic division. So I would recommend starting with this method. This method is going to work for much, much longer, and it's going to be much, much simpler. If you decide that you disagree, or if you decide that you want to be a rebel, you're welcome to use long division and synthetic division. I'm happy to teach those to you. But I would recommend using box method. It's going to save you some time on your homework. When I post the homework, I posted it's three different skills, but it's all the same thing. Like as in we're dividing the same difficulty of polynomials. The only difference is one set shows you examples with long division, one set shows you examples with synthetic, and one skill shows examples with box method. I'm not going to ask you to pick any or all of the methods. I'm just going to ask you to find one that works best for you, and you stick with that one. If you stick with that one, it'll work the whole way through. So there's no penalty, other than some take more time to do, but I've already talked about that. So with that said, you can use any method you want to solve. Here's a couple examples you can work through. I just show it a little differently. Instead of having a long division bar, I wrote them as fractions. But we're still saying the polynomial in the numerator divided by the polynomial in the denominator. Same thing. Okay, so takeaway, we can do some algebraic methods to find x-intercepts of a polynomial function. And three of those methods are long division, synthetic division, and Mr. Jansen's favorite, box method. Good luck with your homework.